Look at your arm right now. Go ahead, take a second and actually look at it. If you are a normal, functioning Homo sapiens, you are staring at a patch of relatively naked, slightly bumpy skin with a few pathetic, translucent hairs sprouting out of it. Now, think about literally every other mammal on the planet. Your dog, a wild deer, a grizzly bear, a common field mouse. What do they have that you don't? A coat. A thick, lush, built-in blanket that keeps them warm, protects them from scratches, and shields them from the blistering sun. Fur is the gold standard of mammalian design. It is the default uniform of the animal kingdom. For over 200 million years, nature looked at fur and said, "Yes, this works, let's keep doing this." And then came us. We are the naked apes. We are the bizarre, fleshy anomalies walking around like we forgot to get dressed. Out of roughly 5,000 species of mammals roaming the earth today, only a tiny handful are hairless. Whales, dolphins, hippos, elephants, and rhinos. That is your country club. And notice a pattern there. The others are either massive, multi-ton tanks that live in boiling environments where trapping heat would literally cook their organs from the inside out, or they live entirely underwater, where fur becomes a soggy, drag-inducing nightmare. But you? You aren't a 6-ton elephant or a slippery dolphin. You are a land-dwelling primate. And your closest living cousins, the chimpanzees and bonobos, are absolutely covered in thick, dark, glorious hair. So, what happened? Why did evolution look at our ancestors and decide to strip us completely bare? Why did we trade our built-in survival suits for sunburns, goosebumps, and a multi-billion-dollar clothing industry? It turns out, losing our fur wasn't just a minor cosmetic tweak. It wasn't an accident, and it wasn't a fashion statement. It was a brutal, high-stakes gamble. It was a radical biological heist that completely rewired our ancestors' bodies, reshaped our brains, and fundamentally changed the way we interact with the universe. If we hadn't lost our fur, you wouldn't be sitting here watching this video. You wouldn't have smartphones, cities, agriculture, or science. Your skin is a canvas of ancient survival, and every single pore is a monument to a crisis our ancestors had to sweat their way through. Let's go back, way back. To understand why we became naked, we first have to understand why we were hairy in the first place. For millions of years, our ancient hominin ancestors lived a pretty comfortable life in the dense, shaded canopies of the African rainforests. They looked a lot like modern chimpanzees, short, stocky, and covered from head to toe in dense black fur. And in that environment, fur was a literal lifesaver. Think of fur as a high-tech climate control system. When the jungle temperature dropped at night, the fur trapped a layer of warm air right next to the skin, acting like a thermos. When the sun beat down through the trees during the day, that same fur acted as a shield, reflecting the solar radiation away before it could blister the skin. On top of that, the jungle floor is a hostile place filled with briars, thorns, and razor-sharp leaves, not to mention a buffet of blood-sucking mosquitoes, ticks, and fleas. A thick coat of hair was a physical shield against scratches and a fortress wall against parasites. If a tick wanted to feast on an ancient ape, it had to navigate a dense, confusing labyrinth of hair just to find the skin, giving the ape plenty of time to pick it off during a social grooming session. For a long time, this setup was perfect. If it ain't broke, don't fix it. But then, the Earth's climate did what the Earth's climate loves to do. It changed. It threw a massive, slow-motion wrench into the gears of our survival. Around 3 million years ago, global temperatures began to shift. The world became cooler and much drier. In East Africa, the lush, continuous rainforests that our ancestors called home began to shrink. The dense canopies fractured, dried out, and pulled back, leaving massive gaps between the trees. The jungle was dying, replaced by something entirely new, the savanna. A vast, open, sun-drenched landscape of tall grasses, scattered shrubs, and a blistering, unyielding sun. This was a massive geographical eviction notice. Our ancestors were forced out of the trees and onto the ground. They couldn't just swing from branch to find food anymore. They had to walk. They had to travel vast distances across open, unshaded territory just to find a patch of fruit or a clean water source. And this is where the old mammalian uniform became a death sentence. Imagine putting on a thick, heavy wool coat, a pair of fur-lined gloves, a winter beanie, and then going for a 5-mile jog in the middle of the Sahara Desert at high noon. That is exactly what our ancestors were dealing with. On the open savanna, the sun isn't a distant light, it's a hammer. It beats down directly onto the top of your head and body. In the forest, the trees block the wind, but on the savanna, the air moves, except that air is hot, dry, and unforgiving. When you are walking or running under that kind of heat, your muscles generate a staggering amount of internal heat. Not a little bit, a lot. Your body becomes a literal furnace. If you can't get rid of that heat, your internal temperature starts to climb. 38 degrees Celsius, 39 degrees, 40 degrees. At that point, your proteins start to denature. Your cells begin to panic. Your brain, which is essentially a highly sensitive, liquid-cooled supercomputer, hates heat more than anything else in the world. If your brain gets too hot, you don't just feel uncomfortable, you hallucinate, your organs shut down, and you die. Every animal on the savanna faces this exact same thermal crisis. But they have different workarounds. Lions and leopards hunt at night or rest in the shade during the hottest parts of the day. Antelopes and zebras have specialized cooling systems in their snouts, panting rapidly to cool the blood before it reaches their brains. But panting is incredibly inefficient if you're trying to move long distances. It forces you to take short, shallow breaths, which means you can't run fast or far without suffocating. Our ancestors couldn't just sit in the shade all day, they would starve. They couldn't pant effectively because they needed deep, rhythmic breaths to power their new, upright walking posture. They were stuck in a biological bottleneck. They needed to move, they needed to hunt, they needed to forage, but their fur coats were literally cooking them alive. Evolution needed a radical solution. And it found one by tweaking a feature we already had but barely used: sweat. Every mammal sweats, but most of them do it terribly. Dogs sweat through their paw pads. Horses sweat through their skin, but their sweat contains a protein that turns it into a thick, foamy lather that gets trapped in their hair, making it highly inefficient at actually cooling them down. Most mammals rely on apocrine glands, which secrete a thick, oily fluid directly into hair follicles. It's great for marking territory and smelling distinctive, but it sucks at temperature regulation. Humans, however, went all in on a completely different type of plumbing: eccrine glands. Eccrine glands are thin, watery spigots that open directly onto the surface of the skin. They don't secrete oil, they secrete a mixture of water and a tiny bit of salt. When your body heat rises, these glands open up, flooding your skin with moisture. As the hot, dry air of the savanna moves across your wet skin, that water evaporates. And here is where the physics gets beautiful. Evaporation isn't just water disappearing, it's a phase change. To turn liquid water into water vapor, you need energy. The water absorbs the thermal energy directly from your warm skin and your superficial blood vessels, lifting that heat up and carrying it away into the atmosphere. It is an incredibly elegant, highly effective refrigeration system. But there was a catch. A massive, glaring flaw in the design. If you have a thick coat of fur, eccrine sweating is completely useless. The water gets pumped out of the skin, but instead of evaporating into the open air, it just gets trapped in the dense mat of hair. The hair becomes soggy, heavy, and matted. Instead of cooling you down, that wet blanket of fur creates a humid microclimate right next to your body, trapping the heat inside like a primitive greenhouse. So, around 2 million years ago, a new creature emerged on the African scene: Homo erectus. And Homo erectus was facing a choice: keep the fur and stay slow, shaded, and limited, or lose the fur, turn the sweat glands up to 11, and inherit the earth. We chose the sweat. Slowly, generation after generation, a genetic mutation began to spread. The genes responsible for growing thick terminal hair across the body started to switch off, while the genes responsible for planting eccrine sweat glands multiplied exponentially. The fur thinned out. The naked skin was exposed to the breeze. Suddenly, the sweat could evaporate instantly. The results were a biological superpower. Because we could sweat directly from our bare skin, humans became the ultimate endurance athletes of the ancient world. A cheetah can sprint at 70 miles per hour, yes, but it can only do it for a few hundred yards before its core temperature reaches 41 degrees Celsius and it has to stop, panting and exhausted, to avoid brain damage. A human? A human can just keep walking and running and trotting, kilometer after kilometer, mile after mile, under the blazing midday sun. We developed a hunting strategy called persistence hunting. We didn't need to outrun a kudu or a zebra in a sprint. We just had to find one, startle it, and keep jogging after it. The animal would bolt, heat up, stop in the shade to pant, and just as it started to cool down, the naked, sweaty ape would show up again, jogging at a steady, unrelenting pace. We would force the animal to run during the hottest part of the day until its system completely overheated, collapsing from heat exhaustion without us ever having to throw a single spear. Losing our fur turned us from prey into the most terrifying, relentless ghosts of the savannah. But wait, if losing our fur was such a massive evolutionary cheat code, why didn't every other animal do it? Why aren't there naked lions, naked zebras, and naked baboons running around the Serengeti? Because, as with everything in evolution, there is no free lunch. Dropping your fur coat is an insanely risky move that comes with a mountain of terrifying side effects. And the fact that our ancestors survived them is a miracle of biological adaptation. The first major problem with being naked on the savanna is obvious: sunburn. Underneath their thick fur, chimpanzees actually have very pale, pinkish-white skin. It's protected from the sun's harsh, ultraviolet rays by their hair. But when our ancestors dropped their coats, that pale skin was suddenly exposed to the raw, unfiltered radiation of the equatorial sun. UV radiation is a cellular wrecking ball. It doesn't just give you a painful sunburn, it mutates your DNA, causing skin cancers that can kill you long before you have a chance to reproduce. But even worse than cancer is what UV light does to a vital nutrient in your blood called folate, or vitamin B9. Folate is the fundamental building block of life. If a pregnant woman lacks folate, her baby can develop severe, fatal birth defects of the brain and spine. If a man lacks folate, his sperm count drops drastically. UV light literally destroys folate as it passes through pale skin. If our ancestors had stayed pale and naked, the human race would have gone extinct within a couple of generations due to reproductive failure. So, nature hit back with a shield: melanin. Melanin is a natural, dark pigment produced by cells called melanocytes. It acts as a biological umbrella, absorbing dangerous UV rays and scattering them before they can damage the DNA or destroy the folate in the bloodstream. Genetic evidence shows that right around the exact same time our ancestors lost their body hair, around 1.2 million years ago, a gene called MC1R underwent an intense evolutionary selection. This gene turned our ancestors' skin from pale pink to a deep, rich, dark brown. We didn't just become naked apes, we became dark-skinned, sweat-fueled endurance machines. The dark pigment was the essential armor that made our nakedness viable. But the sun wasn't the only threat. What happens when the sun goes down? The savanna is a land of extremes. During the day, it is a furnace. At night, the temperature plummets. Without a thick layer of fur to trap heat, our ancestors would wake up shivering, freezing, and expending massive amounts of precious caloric energy just to stay warm in the dark. To survive the freezing nights, we had to invent something that no other animal could: external culture. We had to tame fire. Fire became our nocturnal fur coat. It provided the warmth that our skin no longer could, drawing our ancestors together into tight social circles around the hearth at night, fostering language, storytelling, and community. We also began to take the fur coats of the very animals we hunted and drape them over our own shoulders. Think about the exquisite irony of that. We lost our own biological fur, only to use our superior, sweat-fueled brains to hunt down other animals and steal theirs. And then there was the parasite problem. Remember how fur protects animals from ticks, fleas, and lice? You would think being naked would make us less appealing to parasites, and you'd be right, mostly. Flying insects like mosquitoes love bare skin because there's no hair barrier to block their needles. But creeping, crawling parasites like lice faced a massive real estate crisis on the human body. When we lost our body hair, we didn't actually lose our hair follicles. This is one of the biggest misconceptions about human biology. Humans actually have the exact same density of hair follicles on our bodies as a chimpanzee of comparable size. The difference is that our body hair shifted from thick, dark, terminal hair to microscopic, virtually invisible, transparent, vellus hair. It's the peach fuzz covering your cheeks and arms. To a louse, that peach fuzz is a barren desert. There's nowhere to hide, nowhere to glue eggs, and nowhere to cling onto. As a result, the ancient lineage of human head lice got trapped on the only remaining island of thick hair left on our bodies, our heads. In fact, scientists have actually used the evolution of lice to track exactly when humans started wearing clothes. By studying the genetic divergence between head lice and body lice, the kind that lives exclusively in clothing fabrics, geneticists discovered that body lice didn't even exist until about 170,000 years ago. That tells us that for over 1 million years, our ancestors walked around completely, utterly naked, relying purely on dark skin, fire, and their wits to survive, before finally inventing the first primitive outfits. But this leaves us with one final, baffling question. If we went through all this trouble to shed our fur, why did we keep it in a few highly specific places? Why do you still have a mop of hair on your head? Why do we grow thick patches of hair under our armpits and around our pubic regions when we hit puberty? If hairlessness was the goal, why didn't evolution just finish the job? Let's look at your head first. When you stand upright on the savanna, the sun doesn't hit your chest or your back very well. It hits the very top of your skull. Your brain is sitting right beneath that bone, and as we established, your brain hates heat. If you shave a human head and put them out in the desert sun, the heat radiating through the skull is enough to cause severe heat stroke remarkably quickly. The hair on your head stayed behind to act as a localized parasol. It forms a thick, springy barrier that traps a layer of air between the sun and your skull, preventing the heat from conducting directly into your brain. And notice that in populations native to equatorial Africa, where the sun is most intense, the native hair texture isn't long and straight. It's tightly coiled and curly. This isn't random. Tightly coiled hair creates a three-dimensional structure that maximizes air ventilation while completely blocking the sun's rays from touching the scalp. It is an engineering masterpiece. What about pubic and underarm hair? Why do we get that only after we reach sexual maturity? There are two main theories here, and they both highlight just how weird our evolutionary journey has been. The first is friction reduction. When you walk bipedally, on two legs, your limbs rub together. Your arms swing against your torso, and your thighs brush past each other. Over kilometers of high-speed persistence hunting, skin-on-skin friction causes horrific chafing and raw sores. Coarse, curly hair in those high friction zones acts like a collection of tiny biological ball bearings, allowing the skin to slide smoothly over itself without tearing. The second theory is a chemical beacon. Underarm and pubic regions are packed with those ancient apocrine glands we mentioned earlier, the ones that secrete oils and pheromones. Hair in these regions acts like a perfume diffuser. It traps the chemical scents produced by your mature body and broadcasts them into the air, signaling to potential mates that you are fertile, healthy, and ready to reproduce. It's a localized, hairy radio tower for your scent. So when you look at yourself in the mirror, you aren't just looking at a weirdly bald primate. You are looking at a living blueprint of an ancient war between heat, environment, and intellect. Losing our fur was an incredibly dangerous gamble. It exposed us to predators, parasites, sunburns, and lethal cold. But it bought us something invaluable: time. It gave us the ability to hunt when every other predator was paralyzed by the heat. It forced us to develop big, complex brains to build tools, control fire, create clothing, and construct shelter to compensate for our missing coats. Our nakedness didn't make us weak, it made us adaptable. Instead of waiting millions of years for evolution to grow us a thick coat for the Arctic or a thin coat for the desert, we just changed our clothes. We took control of our own environment. We traded our fur for our humanity. And that pathetic little patch of peach fuzz on your arm? That is the receipt for the transaction.